Hello, my name is Mark Burbridge and I'm here to explain and illustrate the technology, methods and advantages of concrete piles, both precast and cast in situ, including plant and typical ground conditions for major works, for my production management assignment 1. But first off, I would like to talk to you about a brief history of piling. While essential to modern superstructures, the pile foundation has been around for many centuries. The original piles were stems or trunks of trees fashioned using bronze or stone tools. And this proves that primitive man was already engineering and designing solutions to unstable and unsuitable strata using natural materials that would surround him at the time. This would have gone a long way into keeping them and their families safe from attack from hunting animals and potentially even rival tribes. While technology and materials have changed over the centuries, the principles remain the same. Here's an early example of a manual pile driver, which you can see there has manually operated winch, replaceable timber hammer, and a timber pile there in the centre if you can just make that out. Ground conditions will have a major effect on which type of foundation is specified in your construction site, but to enable us to find out what types of foundations will need to be specified, a number of different tests can be undertaken. These include test pits, trenching, boring, and in situ testing. Test pits are usually rectangular or square in shape, and large enough and safe enough for the operatives to be able to detail the makeup of the soil from within. Shoring of the pit is only required when the pit reaches a depth of over 1.2 metres or it's in unstable ground, and this is usually done with sheet piling. GPS locations of pits can easily be obtained and transferred to the CAD drawings so they can be accurately depicted on the site layout plans. Trenching is similar to trial pits, except in trenching the pit is elongated over a longer distance. Elongating the trench allows the engineers to establish how the subsurface conditions can change over various parts of the site in one go. The same principles are applied as the trial pits. Each trench is to be numbered and recorded on site and on a plan so the engineers can establish which areas the data was recorded. Once the engineers have processed the information taken from the trial pits and trenches, they are able to specify the appropriate foundation types. Boring provides the opportunity for the engineers to physically remove the soil or rock and take them away for testing, thus enabling them to inspect the soil without major disruption and excavation to the site. With boring, there are many different things that need to be recorded, such as a drilling method, drill bit type, run lengths and intervals. Should any of these above items not be properly recorded, it could have an effect on the results in the geotechnical investigation. Boring also allows the engineers to establish the water table with greater ease than it does with trial pits, trenching or in situ testing. In situ testing methods include standard penetration tests, which penetrate via drilling, and cone penetration tests, which penetrate via direct push. These tests can go some way into showing the engineer the relative density of the soil by repeatedly hitting a piece of apparatus with the same amount of force each time. After each blow, the engineer would measure the distance that the apparatus disappears. If the apparatus disappears rapidly, then the makeup of the soil is not very dense. And likewise, if the apparatus takes a large amount of blows to disappear, then it's very dense. Moving on to cast in situ concrete piles. These are prepared by using rig machines on site to core the ground to the desired depths and then mass fill with concrete. Without the use of piling rigs, cast in situ concrete piles would not be able to be specified, as we would not be able to excavate to the required depths. This is another way in which man has used technology to ensure that the best and fastest processes are used on site to get the best end results. It's up to the engineer to specify if the concrete piles are to be reinforced or not. The best time to add this reinforcement would be before the mass pour begins. Inclusion of foreign material within the pile can negatively impact the structural integrity of the pile. One way that foreign material can be included in the pile is via a wall slip, which could create gaps over the length of the pile. We could also reduce the risk of foreign material entering the pile by either fully lining the core or by lining the first 2 to 5 metres of excavations, should this be where the unstable soil is. Here are some advantages of cast in situ concrete piles. Custom piles of any size or length can be constructed on site. Damage during transportation of precast concrete piles is common, and this eliminates the risk. The lack of vibration from installation plant means that any adjoining structures are safe from damage. They are more suitable to sites where their soil has poor drainage properties, as the process does not significantly impact the soil immediately surrounding the pile. Precast concrete piles are piles that are formed off-site and then transported to site ready for installation. The process is similar to the example of primitive man that I showed earlier in this presentation, but is much less labour intensive to install than the original. Once the pile has been formed and transported to site, it needs to be driven into the ground by a piling rig. This is a piece of specifically designed technology and is another way in which man has made the process of piling easier and more beneficial over the years through technology and innovation. One of the main risks faced by precast concrete piles is damage to the pile head during the during the driving process. To ensure that the risk is minimalised, the pile will not be transported and driven until the concrete has reached its minimum 28-day curing time. During the process of driving, a sacrificial piece of packing material such as timber or rope is attached to the hammer to minimise the risk of damage to the head of the pile. Should a single piece of precast concrete pile not reach a sufficient depth, then another will need to be attached during using a joint called a splice. And here we can see there are many different splices which can be specified. Precast concrete pile advantages. They're often the most cost-effective method for contaminated or brownfield sites due to the minimal amount of spoil produced. A wide range of piles can be chosen from. Pre-formed piles are manufactured to factory level standards and quality control. They can be manufactured to their own required lengths, individual specifications, and are not affected by the water table. Precast concrete piles suit a wide variety of ground conditions. I'd now like to thank you for listening and open up the floor to any questions you may have.